Hello guys, today I am going to explain how to model a pin diode in HFSS and how to achieve the frequency reconfigurability. So before going to the modeling in HFSS, we should know the equivalent circuits of RF pin diode, RF switch, as well as the equivalent circuit of the pin diode in on and off state. So in on state, a pin diode behaves like a series combination of inductor with a resistor. So in off state, a pin diode behaves like a series combination of inductor with a parallel combination of resistor and capacitor. These parasitic values, the inductance, capacitance and resistance value you can get from the technical data sheet of a particular diode. So now a pin diode RF switch consists of two capacitors and one pin diode connected in series. So these are RF blocking capacitor as well as DC blocking capacitor, because we required some DC supply to turn on and off this pin diode, so that may distort this RF signals. So to block those DC signals, these capacitors are placed. Again, there are different configuration of pin diode RF switches. You can go through it. So now we will go for the modeling of pin diode RF switch in HFSS. So here one Mender line based microstrip antenna I have designed. It's a monopole antenna, there is no ground. So, and I have placed a pin diode RF switch over here. So simply by modeling we can turn it off and on, and we will see the impact on the operating frequency of this particular antenna. So from this there are two capacitors. So these two blue strips are capacitor, and these two strips, orange and this pink, one representing the equivalent circuit of pin diode, this one, either this one or this. So how to model this as a capacitor? In HFSS we can model a particular strip as a perfect electric conductor, some material, or a particular resistance, inductance or capacitor. So here assign boundary lumped RLC. So before going to assignment a particular value, so we need to define the current direction, means from which direction to where the current will flow. So here new line. So I am assuming the current is flowing from this to this direction. So now I will simply give the value, say 1 microfarad. So now this strip will represent a capacitor. Similarly here I will assign boundary lumped RLC, new line. So okay, values I have not given. Okay, so now these two capacitors I have modeled. So now consider initially my pin diode is on. So in case of on, it should behave like a inductor and capacitor. So you have seen assign boundary. So there are three different values: resistance, capacitance and inductance. At a time you can provide all these values, but it will represent a parallel combination of resistance, inductance and capacitor. Since here we are expecting the series combination, one resistor and one inductor only, so here that's why I have taken two different sheets. One will represent inductance, another will represent resistance. So for example, this is inductance 0.4 nanohenry, new line I have to assign. So now this is our inductor. Similarly here I will assign resistance in on state 1 ohm. So now this combination of four sheets will represent a pin diode in on state. So now what about the size of these seeds that you can take depending on the size of practical size of your pin diode. Generally if you are going to take the chip diodes, so the dimensions are in zero point 0.7 millimeter, around 0.7 or 1 millimeter. Similarly for capacitors also it is in the range of few millimeters, 0.7, 1 or 1.2 millimeters. So that idea you have to take, which type of components you are going to place over here and what should be the spacing between these two. So that you will have to take care, because the soldering itself is a complicated task, because the devices are very tiny, and also after that you have to place the wiring over here. So that care you are supposed to take. So now here our diode is in on state. Now simply I will check it. Rest of the design I have already done. So from here you can see lambda RLC models are there. Okay, so simply I will simulate it. Now the simulation is complete. We'll see. So now our resonant frequency is around 1.07 gigahertz. So now I will turn off the diode and we'll compare the return loss operating frequency in on and off state. So for that purpose I will simply export this graph. Say this is on. So now I have to turn off the diode. So in case of off condition it should behave like this: an inductor, a series combination with resistor and capacitor. So as I told you, so this is our resistor, this is already inductor. So here parallel combination we have to do. In off state you can assume it is in the range of 20 kilo ohm, and here 0.5 picofarad. So now this combination of four strips are representing a RF switch in off state. So simply I will simulate. So we'll see the result. So see, earlier it was 1.07, now it is 1.28. So we can also compare the earlier graph. See, this was when the pin diode was on and this is when pin diode was off. Actually this is due to the operating frequency depends on the current path length. So when pin diode is off, the length is less. So that's why when there is a smaller length, means smaller wavelength, and hence we are getting higher frequency. And when pin diode is on, so the current path length is larger. So that's why the wavelength is larger and we are getting lower frequency. So in this way, by incorporating pin diode in a microstrip antenna, we can achieve the frequency reconfigurability. So thank you very much for watching this video, and I think this will be very helpful for your project work. Thank you very much.